Hello student. In today's session we will start our second unit, that is kinetic analysis of the mechanism. Okay. And in this unit we will discuss the analytical method. There are two methods to analysis or to do the kinetic analysis of the mechanism. First one is the analytical method and second one is the graphical method. So in this chapter we will discuss that analytical method. Okay. So first topic or first part of this unit is find out the equation of displacement, velocity, acceleration of slider crank mechanism. In previous unit we have discussed about that what is the slider crank mechanism. Slider crank mechanism, suppose this is the slider. Okay. This one is the slider. This is the connecting rod. This is the line of action. So this is the point. So we consider this is the point O. This is called as the crank. This is called as the crank, and we got it is R is the length of the crank of the slider crank mechanism. This is the slider. This is called as the connecting rod. Connecting rod. So we consider this is the point. On here we consider the point. So this is the slider. This is connecting rod. This is the crank, and this is the fixed wheel. As this crank is rotated, according to this slider will move. Okay. Here we consider L is the length of the connecting rod. L is the length of the connecting rod. R is the radius or length of the crank. Okay. So if we draw this perpendicular here, we will get the point M. Okay. Then we will draw one circle which radius is equal to. Suppose this is a circle having a radius R, or which is equal to the length of the connecting rod. Okay. Now, when this crank is completely on this horizontal line, then this C point will appear here, and it is called as the inner dead center. I is inner dead center. And when this C point is moved along this line, and when it reaches to here, we call it the outer dead center. Okay. Now, when this C point is at inner dead center, this point will move at the extreme to the left hand side. And when this point C reaches to outer dead center, then this P point will reaches to the extreme right hand side. Okay. Now we consider a general position. We will consider, suppose this is the first position. We consider here P1 is the first position of this slider, and P is the any position of the slider. P1 is the first position of the slider, and P is the any position of the slider. Okay. Then we call it this distance. Suppose we consider as an XP. XP. Okay. So first of all we will give the nomenclature here. R is the, what is R? R is the radius of crank. Radius of the crank, or we call it as the length of the crank. L is the length of the connecting rod. Length of connecting rod. L is the length of the connecting rod. Okay. Now we will take N is equal to L upon R. Obliquity ratio. N is called as the obliquity ratio, and it is equal to L upon R. Okay. So we will mark this angle as a phi and this angle as a theta. So what is phi? Phi is the angle between connecting rod is the angle between connected rod and the line of stroke. And line of stroke. Okay. Now, what is theta? Here theta is the angle between crank and inner dead center. Angle between crank and IDC means the angle made by this crank, okay, with respect to the inner dead center. Okay. Now XP. XP we consider it as a displacement of the piston. Displacement of the piston. Displacement of piston. Now omega. Omega is the angular velocity of the crank. As this crank is rotating, we consider this as a crank is rotating with the angular velocity omega. So angular velocity of crank. Angular velocity of the crank. Then alpha. Alpha we call it as the acceleration of the crank. Angular acceleration, sorry. Angular acceleration of crank. Now, omega c. Omega c is the angular velocity of the connecting rod. Angular velocity of connecting rod. And alpha c. Alpha c is the angular acceleration of the connecting rod. Okay, these are the nomenclature. Now we have to find out the equations of displacement of the piston, angular velocity of the omega is the angular velocity, alpha is the angular acceleration of the crank. We have to find out the equation of displacement of the piston, velocity of the piston, and displacement of the piston, velocity of the piston, and acceleration of the piston. Sorry, omega is the angular velocity of the crank and alpha is the angular acceleration of the crank. Okay. So I will draw the small diagram so we will easily understand. This is the piston. This is connecting rod. This is the line of friction. This is point C. This is point O. This is point P. This is point P1. The distance is X P. We mark this other point, and this angle is suppose phi. This angle is theta. This is the L point. Sorry, this is the L. This is R. Okay. And omega. Now, consider from this image we have to write the equation that is xp. Displacement of the piston. First point is the displacement of piston. Displacement of the piston. So displacement of the piston is given by xp. X for displacement, P for a piston. And displacement of the piston is equal to P1 to P. When suppose we consider initially the piston is at a position P1 and when it moves from P1 to P, it travels some distance, we call it as a xp, and this is given by xp is equal to P to P1. Okay. Now, if we want to write this, we can write it as also O1 to P minus O2 to P. P minus O to P. Okay, it can be, if we want this distance P1 to O. What is P1? P1 is the initial position of the piston. And what is the initial position of the piston? When this point is reaches to the inner dead center. Means over to P is equal to R plus L. R plus L. How we write this as R plus L? Suppose this is the position of the piston connecting our crank. When this crank is reaches to the inner dead center, means this is R, this is L. Okay, this point C, O, P. Okay, here is O point, this is point C, and this is point P1. Or it is equal to R, it is equal to L, it is equal to R. When this C point is reaches to inner dead center, means this piston will reaches to the extreme left, and therefore the O to P1 is equal to R plus L. Okay, minus over to O to P. This can be written as R into, here is R, and we want this distance O to M. O to M is equal to R into cos of theta. Plus, we want this distance P to M. P to M is equal to L into cos of phi. L into cos of phi. Okay. So, xp is equal to this. If we simplify it, we will get R into 1 minus cos of theta plus L into 1 minus cos of phi. If we simplify this bracket, we will get xp is equal to R into 1 minus cos of theta plus R L into 1 minus cos of phi. Okay. Now, if we consider the triangle PCO, if you consider a triangle PCO, here CM is common. Here CM is common. So L into cos of phi, L into cos of phi is equal to R into cos of theta. In triangle PCO, CM is common. If we take this CM, if we consider triangle PCM, then CM is equal to L into cos of phi. Similarly, when we consider triangle OCM, CM is equal to R into cos of theta. Okay, so cos of phi is equal to R upon L into cos of theta. Okay, now cos of phi is equal to cos of theta divided by n. Cos of theta divided by n. Sorry, here instead of cos, here is the sine. Instead of cos, here we will get the term sine. I will explain once again. L into sine of phi is equal to R into sine of theta. Okay, so sine of phi is equal to R upon L into sine of theta, and R upon L is equal to 1 upon n into sine of theta. So sine of phi is equal to sine of theta divided by n. We will get this relation. Okay, from this triangle PCM and OCM. Okay, now we know that sine square of phi plus cos square of phi is equal to 1. Sine square of phi means sine square theta plus cos square theta is equal to 1. Similarly, sine of phi plus cos square of phi is equal to 1. Okay. So cos of phi is equal to square root of 1 minus sin square of phi. Okay, if we put this value of sin phi here, we will get cos of phi is equal to 1 minus sin square of theta divided by n. Sin square theta divided by n square. Okay, and it is equal to n square minus sin square of theta divided by n cos of phi. Cos of phi is equal to square root of n square minus sin square of theta divided by n. We will mark this as equation 1. Now put this value of cos phi in equation 1. Therefore, we have equation that xp is equal to r into 1 minus cos of theta plus L into 1 minus cos of phi. We will put the value of cos phi here. We will get r into 1 minus cos of theta plus L into 1 minus square root of n square minus sin square of theta divided by n. Okay, so which is equal to r into 1 minus cos of theta plus L into n minus square root of n square minus sin square of theta divided by n. And we know that n is equal to L upon r. So n is equal to L upon r. So L upon n is equal to r. So we can write it as r into 1 minus cos of theta plus r into n minus square root of n square minus sin square of theta. Okay. So this is the equation for the displacement of the piston. So we can write it as xp, displacement of the piston is equal to r into 1 minus cos of theta plus r into n minus square root of n square minus sin square of theta. Okay. So this is the equation of displacement of the piston. Okay, this is the equation of the displacement of the piston. Okay. Now we have to find out the second point. First we have to find out the displacement of the piston. Now we have to find out second point, that velocity of the piston. Second point is velocity of piston. How can we find out the velocity of the piston? We know that the simple equation of the velocity is, what is the definition of the velocity? Velocity is the rate of change of displacement. As the time is changes, as per the time how the displacement will change, it is called as the velocity. So velocity is rate of change of displacement. So Vp is the velocity of the piston, and we can write it as it is equal to rate of change of displacement with respect to time dxp by dt. We can simplify it, we can write it as dxp divided by d theta into d theta by dt. As per the chain rule, we can write this dxp upon dt is equal to dxp divided by d theta into d theta by dt. Okay, so it is equal to, and we know that d theta by dt means theta is what? Theta is the angle between crank and the inner dead center. As this omega is changes, this angle is goes on increasing. Okay, means this d theta by dt is called as the angular velocity of the crank. So d theta by dt is equal to omega. So omega into dxt by d theta means we want to take a derivative of this xt with respect to theta. So Vt is equal to omega into d upon d theta, and what is the equation for the xp? Xp is equal to r into 1 minus cos of theta plus r into n minus square root of n square minus sin square of theta. Okay. We have to take the derivative of this. Now, as r is the length of the crank or radius of the crank, so it is a constant. So we will take it as a out. So omega into r into d upon d theta into 1 minus cos of theta plus d upon d theta into n minus square root of n square minus sin square of omega into r. If we take the derivative of 1 with respect to theta, it is equal to 0, and derivative of the cos theta, is minus sin theta. So here this minus this 0 minus sin theta plus we have to take the derivative of this term with respect to theta. Derivative n is a constant, so derivative of this constant is 0 minus derivative of this term. The derivative of this term is equal to 1 upon 2 into derivative of this 1 upon this term n square minus sin square of theta. Then minus sign is in this sin 2 into derivative sign is cos theta into this sin theta. So this is the derivative of this whole term. If we simplify this, omega into r into this minus become plus sin theta plus this minus sign and this minus sign become plus. So this is equal to 2 into cos of theta into sin of theta divided by square root of n square minus sin square of theta. Okay, and this bracket is completed. Here now, if we simplify this omega into r into sin of theta, this 2 into cos of theta into sin of theta is equal to sin of 2 theta. Sin of 2 theta divided by 2 into square root of n square minus sin square of theta. Okay. So this is the equation of Vp, that is equal to velocity of the piston. Now here n, what is n? N is called as the obliquity ratio, and n is equal to L upon R. And always remember that L is always greater than R. L is always greater than R means N is always greater than N is always greater than 1. Therefore, N is always greater than 1. Okay. And sin theta. What is theta? Theta is the angle between this crank and the inner dead center, and it is very small as compared to the N. Theta is very small, and if we take the square of any small term, it is also small value. Therefore, this sin square theta we can neglect, and it is equal to. So we can write it as after simplifying omega p is Vp is equal to omega r into sin of theta plus sin of 2 theta divided by 2n. And this is the velocity of the piston. This is the velocity of the piston. Okay. Now, velocity of the piston. Now we have to find out the acceleration of the piston. The third term is the acceleration of the piston. Acceleration of the piston. So what is the acceleration? Acceleration is called as the rate of change of velocity. So acceleration of the piston is AP, and it is equal to rate of change of velocity, that is dVt by dt. So by chain rule we can write it as also dVt by d theta into d theta by dVt by d theta into d theta by dt. And we know that d theta by dt is equal to omega. So it is equal to omega into dVt by d theta. dVt by d theta. Now, AP is equal to omega into d upon dt. And what is the Vp? Vp is the velocity of the piston. So we can write it as omega r into sin of theta plus omega r into sin of theta into sin of 2 theta divided by 2n sin of 2 theta. Now we consider the velocity of the angular velocity of the crank is constant. Consider omega is equal to constant. What we have considered here? We consider here omega is equal to constant. Okay, so AP is equal to omega. This omega and r multiply this whole term, and this omega is constant and r is also constant. So we can take it at the outside. So omega square into r into d upon dt into d upon, not here dt, here is d theta. There is d theta. So sin of theta plus sin of 2 theta divided by 2n. So it is equal to omega into r. Derivative of sin theta is equal to cos theta plus derivative of sin of 2 theta is equal to cos of 2 theta into 2 is 2 divided by 2n. Will get cancelled, and it is equal to omega square r into cos of theta plus cos of 2 theta divided by n. This is the acceleration of the system. If AP is the acceleration of the piston. can consider here omega is constant. In this equation, we consider that omega is constant. But what happens if we consider that omega is not constant? Means the velocity, angular velocity of the piston is not constant. Then when omega is not equal to constant, then we have to differentiate this equation with respect to theta, that considering omega is not constant. Therefore, AP is equal to omega into d upon d theta into omega r sin of theta plus sin of 2 theta divided by 2. Okay? Now, this r is constant, so we will take this omega into r as constant outside the term, and then we have to take the derivative of this omega into this sin of theta plus sin of 2 theta divided by n. Okay? So we can use here UV rule. So omega remains constant here, omega into cos of theta plus cos of 2 theta divided by n plus we have taken this omega as u into dv by dt. So u is omega and we take the derivative of this term. Plus we have to take this term as same and we have to take the derivative of this omega with respect to theta. So here sin of theta into sin of 2 theta divided by 2n into d omega by dt. D omega by d theta. Okay? Now, as d, we can write this d omega by d theta is equal to d omega by dt into dt by d theta. By using the chain rule, we can write that d omega by d theta is equal to d omega upon dt into dt by d theta. Okay. So d omega by dt. What is d omega by dt? That is the acceleration. What is the omega? Omega is the angular velocity of the crank. Angular velocity of the crank. So if we change this angular velocity with respect to time, it will call at the angular acceleration of the crank. The rate of change of angular velocity, we call it as a angular acceleration. So this omega by dt is equal to alpha. And what is alpha? Alpha is the angular acceleration of the crank. And dt by d theta is equal to 1 upon omega. So this is equal to alpha upon omega. So if we put this d omega upon d theta in this term, we will get right here. We will get AP is equal to this AP is equal to omega into r into omega into bracket cos of theta plus cos of 2 theta divided by n plus sin of theta plus sin of 2 theta divided by n, 2n into alpha upon omega. Okay, and if we take this omega inside out, okay, so omega into r into cos of theta plus cos of 2 theta divided by n plus alpha into r into sin of theta plus sine of 2 theta divided by 2n. Okay. So this is the equation of the acceleration of the piston. This is the equation of the acceleration of the piston when omega is not a constant. Omega is not a constant. So we will write here three different equations, that is xp. So what is the equation of xp? xp is the displacement of the piston. So what is the formula for xp? xp is equal to r into 1 minus cos of theta plus r into n minus square root of n square minus sin square of theta. Okay. So this is the equation of xp, that is velocity of the displacement of the piston. Now we have to write the velocity of the piston. So what is the equation of the velocity of the piston? Velocity of the piston is equal to omega into r into sine of theta plus sine of 2 theta divided by 2n. So this is velocity of the piston. And now acceleration of the piston. Acceleration of the piston is omega into omega square r into cos of theta plus cos of 2 theta divided by n. This is the velocity of the acceleration of the piston when omega is constant, and this is the acceleration of the piston when omega is not constant. Here we have find out three terms of the piston, that is displacement of piston, velocity of the piston and acceleration of the piston. Okay. Now we have to find out the velocity and acceleration of the connecting rod. Here we have find out the velocity, acceleration and displacement of the piston. Now we have to find out the acceleration and velocity of the connecting rod. Okay. So we have found out fourth term, that is angular velocity of connecting. Angular velocity of the connecting rod. Okay. Here, if we consider triangle PCM, in triangle PCM, Cm is equal to L into cos of phi. Cm is equal to L into cos of phi. Okay. And in triangle OCM, Cm is equal to R into, here not cos, in triangle PCM, Cm is equal to L into sin of phi. That is Cm is equal to L into sin of phi. And in triangle OCM, this Cm is equal to R into sin of phi. This Cm is equal to R into sin of theta. Okay. These terms are equal, therefore L into sin of phi is equal to R into sin of theta. Okay. This L upon R into sin of phi is equal to sin of theta. This L upon R is equal to n. So n into sin of theta is equal to cos of theta. Okay. So sin of phi is equal to sin of theta divided by n. n. Now here we differentiating this term with respect to t. Okay, so d upon dt into sin of phi is equal to d upon dt into sin of theta divided by n. Okay, so when we differentiating this, we will get cos of phi into d phi by dt, which is equal to cos of theta divided by n, cos of theta divided by n into d theta by dt, d theta by dt. Okay, now this d theta by dt is equal to omega. So here cos of phi is equal to, and this d phi by dt. What is phi? Phi is the angle between connecting rod and this line of stroke. Therefore, this d phi by dt is equal to angular velocity of the connecting rod. So omega c. So it is equal to cos of theta divided by n into omega. Okay. Now, if we this transfer here, omega c is equal to cos of theta divided by cos of phi into omega upon n. Okay. Now, cos of phi, we know that the value of cos of phi, cos of theta. What is the value of cos of phi? Cos of phi is equal to n minus square root of n square minus sin square of theta into omega upon n. Omega upon n. We have know that cos of phi is equal to square root of n square minus sin square of theta divided by n. Okay, so when we put here, we will get cos of theta divided by square root of n square minus sin square of theta divided by n into omega upon n. Okay, so it is equal to omega into cos of theta divided by omega into cos of theta divided by square root of n square minus sin square of theta. Okay, here theta is very small, therefore we neglecting this term. Therefore it is equal to omega into cos of theta divided by n. Omega into cos of theta divided by n, and it is equal to omega c. So what is omega c here? Omega c is the angular velocity of the connecting rod. Angular velocity of the connecting rod, and it is equal to omega into cos of theta divided by n. Okay, this is the omega c is equal to omega into cos of theta divided by n, and it is called as the angular velocity of the connecting rod. Okay. Now we have to find out the angular acceleration of the connecting rod. Angular acceleration of the connecting rod. The fifth term is angular acceleration of the connecting rod. So what is the acceleration? Acceleration is equal to d omega by dt. So for connecting rod, omega c is equal to d omega c by dt. Okay, so what is, and we can write it as also equal to d omega c by theta into d theta by dt by chain rule, by the law of chain rule. So it can be written as equal to omega into d omega c by dt, d omega c by dt. So it is equal to omega into, what is omega c upon dt? What is omega c? Omega c is equal to omega into cos of theta divided by n. Omega c is equal to cos of theta divided by n. So differentiating with respect to t, differentiating with respect to theta angle, differentiating with respect to theta angle. Okay, so this omega is constant. Here we consider that omega is equal to constant. What is the considering here? We are considering here that omega means angular velocity of the crank is constant. Okay, so it is equal to omega square upon n, omega square upon n into minus of sin theta. So it is equal to omega c is equal to minus omega square into sin theta divided by n. This is the acceleration or angular acceleration of the connecting rod when omega is constant. So what is this negative sign indicate that? This negative sign indicate that as this crank is rotating in this side, okay, as this crank is rotating or as the acceleration is increasing, this theta will goes on increasing. Okay, now this is the angular acceleration of the connecting rod when these omega is constant. So these are the total expression or these are the total equations to find out the displacement of the piston, velocity of the piston, acceleration of the piston, angular velocity of the connecting rod and angular acceleration of the connecting rod. Okay, so it is enough for today's session.